Hello, welcome back to our channel, The Classroom. Today we are back with another chapter of trigonometry of class 10, that is heights and distances. This will be the very last chapter of trigonometry for class 10. And yes, last day also we have discussed. Please go through that chapter. Now, heights and distance is a very short chapter. The two things that we need to remember is the angle of depression and the angle of elevation. Now, what is angle of elevation and what is angle of depression? Let's have a look. Now, as you can see, I have drawn two figures here. Okay, I have not yet named this particular figure now. Let's come to this first. So, this is a right angle triangle. As you know, for trigonometry, we always consider a right angle triangle. This is at B, it is right angle. Okay, and this is a particular angle. Now, this, you know, this is a hypotenuse, this is a perpendicular, this is a base. Now, at this moment, for this particular chapter, heights and distances, I am considering AB as a tower. Okay, and supposing here at point C, a person is standing. So, if a person is standing and viewing an object at A, so this particular line becomes a line of sight. That is, CA becomes the line of sight. And this is the horizontal. Okay, so the angle made with the line of sight and the horizontal is this particular angle that is formed is called the angle of elevation. This angle is known as angle of elevation. This, supposing this to be a tower and here is an object. If a person is seeing from C to A, that is which is at a greater distance, at a higher distance, okay, the line through which it is seeing, that is known as the line of the sight, and the line of sight makes an angle with the horizontal, which is known as the angle of elevation, right? So this was a concept of angle of elevation. Now supposing A, B and C again, okay, now the person is at A. This person is viewing an object at C, right? That means he is looking down. So this is again the line of sight. I am writing LOS, please don't misunderstand. This is line of sight, okay? And this line of sight, we are considering this particular dotted lines as the horizontal, okay? So the angle made between the line of sight and the horizontal, okay, this particular is known as angle of depression, right? So this was angle of elevation and this is angle of depression. This happens when a person is looking down, okay? So this was a difference, and again AB here is a tower as assumed. So this was all about angle of elevation and angle of depression, which we are going to use in the sums. Now the sums are very easy. It's a very short chapter, as I have told you before. Now let's go to one easy sum with angle of elevation. Okay, how you will understand. Now coming to a example, the length of a shadow of a vertical tower is √3 times its height. Find the angle of elevation of the sun. Now the main thing in this part is you have to draw the diagram as soon as you get a question. Okay, especially for this particular chapter, heights and distances. And if it is given, it's good. In most of the problems, you have to draw the diagram yourself. Okay, so considering AB, first you have to draw a right angle that you know. Okay, considering AB as the height of the tower, which we don't know, so I have taken it as H, and BC is the shadow. So if I am seeing from this position C, okay, so this is the line of sight. Okay, this is the horizontal, so the angle which is made, that is angle of elevation, and I have taken that as theta because we are about to find the angle of elevation. So this BC is the shadow, length of the shadow, which is said that it is √3 times of the height of the tower. So √3 into H. So as I said, I have taken the vertical tower's height as H and the length of the shadow is given √3 H. Angle of elevation, I have considered that as theta. Now we have two things with us, known things. One is the perpendicular, that is the height of the tower, and another one is the base, that is the length of the shadow. So whenever a perpendicular and base is given, we know the ratio that we have to consider for an easy calculation is the tan. So we have taken the tan theta is perpendicular by base, that is AB by BC, which is given already, h by root 3h, that is 1 by root 3. So tan theta is equal to tan 30, because for 1 by root 3 tan's 30 degree gives us this value. So we have taken tan 30. So therefore theta is equal to 30 degree. So angle of elevation that we got is 30 degree. Right? I hope this is very clear to you. Next. Now the second question is, a kite is attached to a string. Find the length of the string when the height of the kite is 60 meter and the string makes an angle of 30 degree with the ground. So I have taken one right angle triangle, and you can see from the question it is given that the height of the kite from the ground is 60 meter. Okay, and the string is making an angle of 30 degree with the ground. So as usual, you can understand that whenever it is making a 30 degree with the ground, that means it's an angle of elevation, right? And AC is the string, okay, and the kite is at position A. So we need to find out the length of the string, and the height of the kite from the ground is given, that is 60 meter. So we have two things with us: the angle of elevation that is given, and we know that we have the perpendicular with us. We need to find the hypotenuse. Now whenever perpendicular and hypotenuse are there, that means the ratio which we can consider is that of sine. So sine 30 degree, we have perpendicular by hypotenuse. So once again, just look at the statements. Let the length of the string AC is x and the angle made with the string and the ground is 30 degree. Height of the kite is already given from the ground, that is 60 meter. So sine 30 is perpendicular by hypotenuse, that is 60 by x. So half, 30 degrees value of sine is half, equal to 60 by x. So cross multiplying, we get x is equal to 60 into 2, that is 120 meter. So length of the string is 120 meter. I hope this sum was also clear to you. These two sums which we did back to back were of angle of elevation. Now coming to one example of angle of depression. Now this is the third example. An observer on top of a cliff 200 meter above the sea level observes the angle of depression of the two ships to be 45 degree and 30 degree. Find the distance between the ships if the ships are on the same side of the cliff. Now as for the diagram, you can see I have drawn AB is the cliff, okay, and the person is at this position A. Now he is looking down to the two ships that is at position C and D. So it is making an angle of 45 degree and 30 degree, okay, but this 35 degree, 30 degree and 45 degree, we have the angles of depression. That means this person is looking down, okay, and the side at which he is or she is seeing the two ships is 30 degree and 45 degree. So I have marked here also as these are the alternate angles. EAD is equal to angle ADB. Okay, that is for 30 degree. And another one is EAC is equal to angle ACB, which is 45 degree. I have marked this so that we can get an easy look for the trigonometrical ratios. Okay, whenever it is they are looking down, a person is looking down from the cliff or from a top position, that gives you the angle of depression. And this AE is the horizontal line over there. Okay, so AB, that is a perpendicular, or the length of the cliff is given 200 meter. Now coming to the ratios part. So we are going to have, we need to find out the distance between the two ships. So this distance between the two ships is what? CD. Now we can get BC and we can get BD, right, from the two triangles. We cannot consider this triangle ACD because it's not a right angle triangle. So we are going to consider two triangles, that is ABC and triangle ABD. Okay, so first coming to the triangle ABC. It is given tan 45 degree. Since we have the perpendicular and the base, we know it goes with tan easily. So we have taken the ratio tan. So tan 45 is AB by BC, that is 200 by BC. So tan 45 is 1 is equal to 200 by BC. Now BC is equal to 200 meter. That we have got. In the second triangle, that is ABD, we have tan 30 degree is equal to, again same thing, perpendicular by base, that is AB by BD, 200 by BD. So we have 1 by root 3 for the value of tan 30, that is 200 by BD. BD is equal to 200 into root 3, that we get 200 into 1.732, that is equal to 346.4 meter. Next is distance between the ships, that is we have said it is CD. So CD means what? BD minus BC. That I have written over here. So we have the values for BD and BC, that is 346.4 minus 200, we get 146.4 meters, right? So this was all about the sum which states that the ships were on the same side of the cliff. If it is asked or said that if the ships are on the different side of the cliff, the diagram would have been looking somewhat like this. That is, this is 45 degree, suppose, okay, and this to be considered as, my diagram will not be proper here because I don't have space here. This is 30 degree. So this is A, B, C and D. Okay. Now for this particular diagram, okay, which is the distance between the two ships, BD, right? That means we can have BC plus CD, which will give us BD. Now we already have the, that is this value for BD, that is here, it is written 346.4 meter. Okay, so you can simply write that VC plus CD, that is equal to BD, which is equal to 346.4 meters. Okay, so this was an addition. So this was a diagram if the ships were on the different side of the cliff, and AC is the cliff here, which is 200 meter. Okay, so this was all about the sum. I hope it is very clear to you. This was the sum for angle of depression. Okay, so this chapter is really very easy, but you have to practice a lot, and the most importantly, you have to draw the diagrams before you start with it. Okay, so this was all about the chapter. I hope you have understood. If you have any doubts, you can comment, and if you have liked this video, please put a like, share it and do subscribe, and please don't forget to press the bell icon. You will get many more notifications. Thank you and have a good day.